In this video, we're going to look at using the factor theorem along with the remainder theorem to so that we can take a polynomial and use synthetic division to determine if a certain binomial is in fact a factor of that polynomial. The factor theorem states that if p of c is equal to 0, then x minus c is a factor of p of x and vice versa. So what that means is that the value of c is an actual 0 of your polynomial, and if we combine that with the remainder theorem, what we can add to this is if you divide the polynomial p of x by x minus c and get 0 as a remainder, then x minus c is a factor of p of x. So we can use this to check factors, or to check binomials, to see if they are factors of a certain polynomial p of x. Let's take a look at an example. Okay, here's our example. Is x minus 4 a factor of x cubed plus 2x squared minus 4x plus 4? So let's try this by synthetic division. What we're going to do, first of all, is identify what c is equal to. Okay, so come back up here to the x minus 4. Remember, that's in the form x minus c. Okay, so we see that c is equal to 4. Now let's set up our synthetic division. Coefficient on x cubed is 1. We have a 2 on the x squared, a negative 4 on x, and a positive 4 there at the end. Okay, what you're looking for here, if x minus 4 is in fact a factor of this polynomial, what we will see happen as we do the synthetic division is our remainder term that'll be here on the end will be equal to 0. So let's work through the problem. We drop the first coefficient, that's a 1. Then we multiply the 1 by the 4 and put that right under the next number 2. Combine those two, we get 6 times 4 is 24. Negative 4 plus 24 is 20. And then we get 4 times 20, which is 80. And as you can see, this is definitely not going to come out to be 0. We combine those two together, we get 84. Okay, so this is the number that we're checking right here. If the, let me scoot up and give myself a little bit of room here to write this. If the remainder is 0, x minus c is a factor. Okay, and the remainder here is not 0, is it? The remainder here is 84. And so what that means is that x minus, whoops, I'm sorry, said it right, wrote it wrong. X minus 4 is not a factor. Now we'll be using this technique in the next, well, not the next section, but in section 3.3 to help us find the zeros of some polynomials that were given. We'll use this to eliminate factors, or eliminate binomials that are not factors of our polynomial, and to check the ones that are factors to make sure that we get 0 as a remainder. So we will be using this technique as we move on through. For right now, in the homework for this section, this is essentially how the question's asked. Now it may be, instead of having the p of whatever written for the remainder theorem, or having the factor given to you here, you may have that part given in a different form, like c may be just handed to you rather than given in the binomial form, so just watch out for that. Be sure that you are changing the sign using the opposite value if you're pulling the c out of the binomial, and if you're just handed c, be sure you're using the c that you are given.